Welcome back to Maths with Mrs. J. We've been learning how to integrate, in particular, polynomials. What we've done so far is we've worked with things like integral of x to the n, and we've said we increase the index by 1, divide by our new index, and have our constant term coming in, because of course the derivative of any constant is 0. Now this has always worked with all the examples that we've done. However, there is one case where it is not going to work. Lo and behold, let's have a look at this one here. Now normally I would say put this in index notation, so that's x to the -1. Now, if we were to use this rule, we would increase our index by 1 and divide by the new index and add c. Doesn't look too good, does it? No. All right, we need to think about this one in a slightly different way. All right, so this rule here that we've been learning about works in every case except when n is -1. Because of course you can't divide by 0. All right, let's have a bit of a look at our next screen and see if we can come up with some ideas. Thinking back to our differentiation topics, you might recall that the derivative of natural log of x is 1 on x. Remember our logarithms? Natural log is log to base e, where e is that very special transcendental number. So if the derivative of natural log is 1 on x, it would follow, wouldn't it, that the integral of 1 on x is going to be natural log of x plus your c. Using our chain rule for differentiation, what we would have got there is we would have got, if we're differentiating, 1 over our ax plus b, but then we would multiply by the a, because that's the derivative of that inner function, which is just a linear function. So it follows that if I just have 1 over ax plus b and I'm integrating, I'm going to get natural log of ax plus b plus our constant, but I'm going to have to divide by a. Sometimes you might already have the a sitting out the front there for you, or sitting here for you, and then you don't need to divide by it here. Let's do some examples and I'll show you how this all works. Alrighty, integral of 2 over x dx. This one's quite nice and easy. It's just going to be twice natural log x. Integral of 1 over x with respect to x is natural log. So integral of 2 over x is 2 natural log x. Okay, here, just checking that the denominator is just a linear function, which it is. The derivative of that is 4. So what we're going to do, we're going to get our 3 times natural log 4x minus 5 plus our c, but we're going to have to divide by that 4. This again is basically using your chain rule in reverse, kind of like we did in the previous video. This one here, all right, again, we're going to get natural log 2x plus 1, 4 times that, and then we're going to divide by 2. Now, sometimes, or hopefully quite frequently, you might start to recognise the fact that the numerator is twice the denominator derivative. So you could go straight to calling that 2 times natural log of that, but we'll just do it in 2 steps here. All right, so just to recap, our rule about our integral of x to the n doesn't work if n is -1. So if n is -1 and we get the 1 over x, we then need to do our natural log of x.